Hi, this video is going to give you a little more detail about predicting the products of decomposition reactions. You've been introduced to decomposition reactions just a little bit and shown how the basic equation is that any one substance can be broken down into two or three or even more than that sometimes simpler substances. And we've seen a couple of examples from the lab and from the previous video. We're going to go a little further on particular kinds of compounds and see how they decompose because they're somewhat predictable, but not quite as simple as maybe a binary compound would be. So a binary compound would be something very, very simple, like water or salt breaking down. Most binary compounds will just decompose into the two elements that make them up rather easily. Sometimes it takes a lot of energy, heat, electricity, something pretty intense to make them split. Other times they break down fairly readily, but most binary compounds can decompose into the two elements that make them up. And so here you see an example, water breaking down into hydrogen and oxygen. It was mentioned in the previous video as well. We could also consider, say, salt, sodium chloride, breaking down into sodium and chlorine. Both of these equations, you'll notice, include elements that are diatomic. And so keep that in mind when you're splitting a binary compound, that there's commonly, though not always, one element that is diatomic when it comes out by itself, maybe even two, like with water. What we're going to look at in this video is that there are several kinds of compounds that are quite common in chemistry that break down in a very particular way. And so certainly we'll call them classes of compounds that we're going to look at here that decompose in a rather predictable fashion. We're going to look at 6 different classes, and if you go back to what we've worked with the polyatomic ions sheet, there were a lot of polyatomic anions on there that were quite common in the compounds that we've practiced so far. Some of them have quite simple ways to learn them in terms of decomposition and how they come apart when broken down. With the polyatomic ion involved, there's always at least 3 different elements in the compound, and so we can't just split it up like we can with water or salt into 2 elements. It's not quite that simple. So with a polyatomic ion, we're going to see that they decompose predictably, though not quite as simply as a compound with just 2 elements in it. So these are the 6 classes of compounds that I'm going to ask you to practice on and get comfortable with predicting the decomposition for. Carbonates, hydroxides, sulfates, chlorates, bromates, and iodates. Now you don't need to list those 6 here because you're going to see each of them gets their own information here over the next few minutes, and so you don't need to list them off as they're going to come in this exact same order in your notes coming up. So we're going to look first at carbonates. Now we see carbonates already in the first lab that we did with reaction types, lab 19. We saw a carbonate compound in copper 2 carbonate breaking down, and that carbonate produced carbon dioxide gas when heated. The general rule is that most any carbonates will do the same thing. Some of them really need to be heated hot, hot, hot. Others, like the copper 2 carbonate you use in the lab, can decompose and give us CO2 rather quickly without a lot of heat. So just a reminder again, from the ones that you saw in the lab, copper carbonate, as a great example, broke down to produce a metal oxide, specifically copper 2 oxide, and carbon dioxide gas. Now you'll notice in these equations that I'll give you with the video today that there are sort of these color codings that go on here to help you see how this fills in. The metal in this example, and for all of them, will be in red, and so you see here copper as the metal in the compound that we start with. Carbonate, the ion carbonate, is shown in green, just to kind of help you pick it out and connect it to the word or to the name. And then carbon dioxide is also shown in green. So where CO3 is our carbonate, that yields us or gives us carbon dioxide, CO2, at the end. The third oxygen in this example stays behind with the copper and gives us the metal oxide. So metal basically is a generic word that we can fit in here and fill in with basically any metal that you want to pick out. Some of those carbonates probably don't exist, but you could choose just about any metal and stick it in there for metal, and the equation would work. Sodium carbonate would give us sodium oxide and carbon dioxide. Calcium carbonate would give us calcium oxide and carbon dioxide. So substitute whatever metal you want in the position of the red word metal or in the position of copper in this equation, and the equation would work out more or less the same. Now keep in mind, we need to be careful writing formulas here. Copper 2 obviously has a +2 charge, and carbonate with a -2 charge. So as you write the formulas for the carbonates or for the oxides, you still need to think about those charges that we've been practicing a lot of and bringing down to give us subscripts on the compounds themselves. The second kind of compound we're going to look at is hydroxides. Hydroxides are probably slightly less common than carbonates in a lot of things that we'll do, but they're out there when we start talking about acids and bases quite often. Metal hydroxides will yield or decompose to produce metal oxides and water. Now notice the last equation for carbonates gave us a metal oxide too, and this one gives us metal oxides once again. So for an example equation, calcium hydroxide. Here again the metal could be any metal you want to choose. A metal hydroxide, in this case calcium hydroxide, is heated to yield calcium oxide and water. It's going to come off as steam or as gas, water in a gaseous form, but water nonetheless. So metal hydroxide yields calcium oxide and water. Notice again here I've kind of used a little bit of color coding to help you. Hydroxides are oxygen and hydrogens, and water is oxygens and hydrogens. And so the hydroxide ion gives us the water. It sort of makes sense that you wouldn't expect hydroxides to give us carbon dioxide because the elements just aren't there. And so think about the anion part, hydroxide or carbonate or the others, in this case helping us to remember what's going to be made. Hydroxides logically would make water, and metal oxide is the other product. So again, you could substitute in here for calcium any metal that you want, and you'll get an equation that works out more or less the same way. Finally, metal sulfates yield metal oxides and sulfur trioxide. And so for our example here, the metal is sodium, so sodium sulfate yields sodium oxide. Again, the metal could be any metal. In this case, it's sodium. So that sulfate gave us a metal oxide and SO3. And notice this is the third one in a row where some compound, a carbonate, a hydroxide, a sulfate, will yield an oxide, a metal oxide, as a common product of all three of those. Again, don't try to keep track of 6 different kinds of compounds as I give you each of the 6, but remember that they have common things. In this case, those first 3, each of them produces a metal oxide, so that's a common denominator, a common product. And then it's the other product, carbon dioxide or water, or in this case, sulfur trioxide, that sort of sets them apart. SO4 here in green gives us SO3 when heated. And if you look back at each of the 3 examples, that sort of template works for all 3. So we have carbonates, hydroxides, and sulfates, each of which produce an oxide. And so we keep those 3 sort of side by side here. I'm just kind of repeating it for you just so you can see the combinations are that similar right next to each other. The oxide is that common product that's made in these first 3 compounds. Now, the other 3 classes have something in common too. They're a little different, but there's these 3 and then there's the next 3. And so we'll treat those sort of all in one group as we go on and look at the final 3 compounds that you're responsible for. And those are these, the chlorates, the bromates, and the iodates. Now, notice chlorine, bromine, and iodine are at the root of each of these ions. And so chlorine, bromine, and iodine, all being halogens, are part of the same family or group on the periodic table. And since they're in the same family or group, we talked last unit about how that means they're going to have similar properties. Sure enough, they behave in a very similar way here, even in their ate form. Chlorate, bromate, and iodate have similar properties, just like chlorine, bromine, and iodine have similar properties. And so we're treating them as 3 different compounds, but sort of as a triplets, if you will, in that they behave very similarly. Each of them produces oxygen gas, and so that's the common denominator here. In the last set of 3, they all produced oxides. Here, they produce oxygen gas in common, and you'll see that in the equations as well. Lithium chlorate, and again, we'll do all the chlorates in blue here, so there's a color coding. We'll use potassium bromate and magnesium iodate as our 3 original compounds, a chlorate, a bromate, and an iodate. And again, you could put in any metal you want for each of these. You could shuffle lithium and potassium and magnesium around and work just the same. But we're filling in that metal with one of our cation metals here. And it'll produce then, as each of these decomposes, the chlorate, lithium chlorate, will produce a chloride, lithium chloride. The bromate will produce a bromide, potassium bromide, and oxygen. And the iodate, magnesium iodate, will produce magnesium iodide and oxygen. So notice here that the chlorate becomes a chloride, the bromate becomes a bromide, and the iodate becomes an iodide. It makes good sense, really. What else would they become? And then as you take off the oxygen, that's what's left behind. So the final product there is oxygen gas in each case. And remember, that being a diatomic element means it's going to be O2. So they have that highlighted in yellow that oxygen gas in common. What else they produce, whether it's a chloride or a bromide or an iodide here, is fairly obvious or fairly logical. You're going to get chlorine from a chlorate. You're going to get bromine from a bromate, and iodide from an iodate. And so the products sort of make sense. Now keep these 6 classes, a carbonate, a hydroxide, a sulfate, and now a chlorate, bromate, and iodate. Keep those 6 examples in your notes nearby as you're practicing with the sheet that I'll give you to try, where it's going to throw in a kind of a mixture of all of these and have you try them and see if you can figure out what they'll turn into. Again, keep in mind that the word metal basically can be substituted for just about any metal you want to choose in each case. And after that, they behave more or less in a really predictable way. So you'll be getting a sheet to practice. Give some of those a try, and we'll check your work next time we get together and work on some in class and answer some questions as well. We'll talk to you then.